Good day everyone, my name is Chamaika Bitoyor
And I am John Mark Samson,
and we
we
are
are
the
the
group
group
Lido.
Lido.
So
So
today
today,
we're going
we
to
are going
report
to report
about
about the
Hydrographic
Hydrographic
Survey.
Survey.
So the following are the main objectives for our topic. First, identify the use, operations, and applications of hydrographic surveying. Second, familiarize with the different sounding methods used in hydrographic surveying. So here are the topic outlined for our report. First, the meaning of hydrographic survey, and the second is the purpose of hydrographic surveying. It also includes the equipment of hydrography, the cause of tides, and the types of tides. It also includes the tidal datum and its principle, and the next is the sounding party and the ways on how to locate soundings. It also includes dredging operations, reservoir and sedimentation survey, marine construction and maintenance survey, and the last is the hydrographic survey terms. And for the introduction, Earth's water bodies cover over 70% of the planet, along with the building ships that travel over the surface of the ocean. So it is very important to learn about the seabed and subsurface topography. And this is achieved by conducting underwater studies known as hydrographic surveys. That is why hydrographic surveying plays an important role in construction and planning of docks, harbors, and dams because it is important to ensure that the water depth in and around ports are sufficient to allow for ships to safely enter and berth. And also surveying aids in flood control systems by predicting possible flooding zones and suggesting measures to effectively counter this. So the next slide will be the discussion of what is hydrographic survey all about. So, hydrographic surveying is the process employed in gathering information concerning any body of water and its adjacent land areas. So, hydrographic surveying is a branch of surveying which deals with any body of sea or running water, such as lake, harbor, stream, or river. So, the purpose of hydrographic surveying are the following. So the first is it provides the data for the preparation of hydrographic maps and nautical charts for its purpose in navigation, harbor improvement, yardage, and dredging projects. And the second is for flood control, water supply, hydroelectric power development, pipeline and underground cable crossings, and irrigations. And the third is for determining the volume of impounded water, direction, and velocity of currents, drainage areas, and capacity of containing basin. And the fourth is for gathering data needed for the establishment of tidal datum. And the fifth is for gathering information needed for the design of bridges, dams, seawalls, culverts, sewage disposal plants, lighthouse, docks, and other structures. And the last purpose of hydrographic survey is for locating navigational hazards such as submerged obstructions, sunken vessels, sandbars, rocks, shoals, and coral reefs. So the following are the basic operations involved in a hydrographic survey. First, the reconnaissance. This is done in order to select the most suitable manner of executing the survey and in planning all phases of work. And reconnaissance is always seen to it that the project is completed in accordance with plans and specifications provided for such work. So reconnaissance is like choosing the best area to be surveyed. And the second is the establishment of horizontal control. This step is the establishment of the framework by which land and water features are held in their true relationship to each other. And horizontal control is usually defined by triangulation system, and it is very important to cite all objects which will be useful as the control points because this will be referred to later when locating soundings. And these signals should be erected at locations along the shore which could be used as the defined boundaries at a survey site. And the third is the establishment of vertical control. Prior to the execution of sounding operations, vertical control must first be defined in order that the elevation or stage of the water surface can be correctly referenced. And vertical control data are also needed for the limited topography which will be portrayed on a nautical chart. And this establishment of vertical control is necessary to establish a tide station to observe the tidal fluctuations which will be needed to define the plane of reference for these soundings. And the fourth is the topographic survey. In the hydrographic map or nautical chart, only a relatively narrow fringe of the nearby ground surveys is shown since the expected users are not particularly interested in this area except for a few prominent landmarks which could be used for referencing positions. And also, a topographic survey is performed to include this limited topography. And the fifth is the hydrography. It is the measurement of water depths and establishing the respective locations, which is the most important operations in a hydrographic survey. And different procedures and techniques have been devised to suit various field conditions, scope of work, purpose, and the desired accuracy of the hydrographic survey. And the final product for hydrographic survey is a preparation of a hydrographic map or nautical chart. It is very important to have this because it will be your guide for your desired project. And in the case of subsurface survey for engineering requirements, the end result may be the calculation of water volume contained in a body of water, amount of dredged material, discharge of a stream, or the fluctuations of level in a body of water. And the different kinds of equipment described in the following list are only those which would be used in conducting small-scale hydrographic surveys required for most engineering projects. Such projects usually involve lake, reservoirs, or a harbor, and a small launch or boat. And the first equipment is the sounding craft. Various types are used for hydrographic surveys, and this includes rowboats, motor launches, and small vessels. And most fishing vessels are suitable because they are seaworthy, meaning the fishing vessels have reliable motor performance and can be adapted to the various operations associated with hydrographic surveying. And also small boats or bankas powered with an outboard motor are commonly used only in limited surveys and where the water is calm and current velocities are minimal. And the second equipment is the sounding pole. It is a graduated and rounded piece of lumber about 3 meters long used for taking soundings. It is suitable for use where the water depth does not exceed to 2.5 meters. As you can see, there is a metal shoe which may be weighted to make the pole sink through the water more quickly. And a rounded pole is used since it gives minimum resistance to the flowing water. And during soundings, when samples of material at the bottom of the body of water are desired, the metal shoe is hollowed out to provide a cup-shaped cavity. And the third equipment is the lead line. A lead line or sounding line is usually a length of sash or hemp cord, braided flax or nylon cord with a sounding lead attached to one end. They are seldom used for depths greater than 25 fathoms. Fathoms means it is a unit measurement for water depths and is equivalent to 6 feet. And during soundings, the lead is lowered until it touches the bottom, and at the moment that the line is vertical and taut, the depth is determined from the markings on the lead line. And the fourth equipment is the sounding machine. When the depth of water is too great to permit the use of the lead line, a sounding machine is used. That is a simple device in which piano or stranded wire is used and wound on a reel mounted on a stand. When the reel is turned by hand to raise the weight, and a brake is also provided to stop the rotation of the reel when the lead weight reaches the bottom of the body of water. And the depth of water is measured by the length of wire run out and is indicated by a recording device on the registering sheave. And the weight of the lead used with a sounding machine may be between 6 and 12 kilograms for depths from 15 to 100 fathoms or 100 feet, and a 16-kilogram lead is used for depths up to 1,000 fathoms. And the fifth equipment is the photometer. It is a measuring device with automatically record soundings taken on a moving vessels. This device, which is suitable for use in coastal or deep waters, which records the time required for a sound wave to reach the bottom and for the echo wave to come back. And the range in water depths that can be measured by a photometer is unlimited. Soundings have been made of depths ranging from a few centimeters to 6,000 fathoms. And it is very important that the size, shape, and spacing of these signals must be varied to permit easy identification. For example, where a coastline is low and flat, it is sometimes necessary to erect very tall signals to provide visibility for some distance seaward. The sixth is the signals. When the position of a sounding boat is obtained from a sextant fix, various types of hydrographic signals on shore or buoys anchored in the water are used for sights. And this signal must be clear to be distinguished readily in the mirror of the sextant. And the seventh is the tide gauge. It is an instrument for measuring the height of the tide. In rivers and bodies of water near the seacoast, the water level varies continually. And in order that all soundings in the body of water may be referred to the same level of its surface, the variation in the water level must be known. For this purpose, a suitable gauge that will show the height of the water surface at any instant must be installed in a proper place. And this gauge is known as the tide gauge. And the site at which it is placed is called as tide station. And it is very important that in the selection of a tide station, it should be at a depth of about 1.5 meter below the predicted lowest tide, and it should be located where it will not be damaged. And the last equipment for hydrography is the sextant. It is a portable and handheld instrument used for measuring horizontal and vertical angles. It functions by the physical principle that a light ray striking a plane mirror causes the angle of residence and reflections to be equal. And as you can see, there is a small telescope, and you should adjust the movable arm until the correct reflections of the objects being sighted appear in the mirrors. And after that, you can have the measurement of these objects. And the next will be the causes of tides. As we all know, in practical and economic aspects of our everyday life are affected in many different ways by the tides. For example, tides play an important part in the launching of ships and in floating vessels. And for some reason, the principal cause of the tides is a difference in gravitational attraction exerted by the moon upon different parts of the earth. And the secondary cause is a similar difference in the attraction of the sun. And as we all know, and the periodic nature of the tides is a purely astronomical phenomenon resulting from the daily rotation of the earth about its axis and its annual revolution about the sun and the moon's monthly revolution about the earth. Due to the combination of various tide-raising forces, there exist three main types of tides. First, the semi-diurnal tides. These kind of tides are characterized by too high and too low waters each tidal day, and this tide is found mostly along Atlantic coast of the US and Europe. The second one is a diurnal tide. This kind of tide in which in the long run display one high and one low water each day. And this tide is found mostly in the Philippines and in coast of China. The third one is a mixed tide. This type of tide has two high waters and two low waters each day. And this tide occur mostly along the Pacific coast of the United States. And as you can see in the picture, in diurnal tide, in the long run, it only display one high and one low water each day. Unlike sa semi-diurnal, it display two high and two low waters each tidal day. And sa mixed semi-diurnal, it is a combination of two high waters and two low waters each day. So that ends my part, and the next topic will be further discussed by John Mark Samson.
Tidal datums. Tidal datums are specific tide levels which are used as a surface of reference for depth measurements in the sea and as a base for the determination of elevation on land. So there were four principal tidal datums. 1. The mean sea level, or the MSL, is the datum of first order level net of many countries and is increasingly used as the base for general leveling operations. It is defined as the average height of the sea for all stages of the tide. Second, mean low water, or the MLW, is the mean of all low waters as observed over long periods. It is used as a datum to which depths are referred. The third one, mean lower low water, is the average of all height of the lower of the two low waters that occur in each lunar day. So, the fourth, mean low water springs, or the MLWS, is defined as the mean of the low water of the spring tides occurring a day or two after new full moon. It is obtained by subtracting one half of the range of the spring tides from the mean tide level. Okay. So here's the illustration of the tidal datums. Okay. So sounding party. When locating sounding for a hydrographic survey, the composition of the boat party will depend upon the survey method used. Usually, the following personnel will form the boat party. So, these all personnel are called the boat or are called the sounding party. Okay, so 1. The chief of party directs all surveys operations of the party. So, he is the leader or he is the one who leads for the survey. Is for second the instrument man. Set up the instrument to be used in hydrographic survey. So he is the one who set up all the instruments that will be going to use for the survey. Okay, so third, the recorder. The one who records all the data gathered during the survey operation. Next is the leadsman. Handles the lead line of the sounding rod. Next, it's a coxswain. The one who is responsible for steering the boat on the selected compass bearings or ranges. Okay, so next, the lookout. The one who looks up and watch over the water surroundings for any hazardous materials. So he is the in charge for the safety of the party. Okay, so next is the signalman, the one who alerts the shore party that the sounding is about to begin. So he is the one who signals the party that the sounding is about to begin. Okay, so last, the photometer attendant. In depth water surveys where photometer is employed, the attendant focuses full attention in this instrument. So he focuses only on the photometer. Okay. Okay. So various methods used for locating soundings. 1. The two angles from shore. A common use for locating soundings is to observe directions to the boat simultaneously from two instrument stations. So here's the illustration for that. The two angles from shore. Okay, so number 2. Two angles from boat. In order that the position of a boat used in sounding could be located and plotted on the map, two angles need to be simultaneously observed from the boat to the three fixed points on the shore. So here's the the illustration for the two angles from both. Okay, so as you can see, there are from the boat to the shore there are three lines, and for for the sounding could be that for the sounding or for the sounding to be located plotted on the map, it is a must that the two angles from the boat to the shore must be observed simultaneously. Okay, so number 4, distances along a cross rope or wire. Locating soundings by stretching a graduated wire or cross rope across a narrow stream is a method suitable for surveying detailed cross sections of rivers and channels. 5. Direction and vertical angle. A convenient method of locating soundings where there is a cliff or high bluff is by observing vertical or depression angles with a transit or a theodolite. So the advantage of when locating a soundings in an area where there is a cliff, the advantage for that is that um, you're just gonna have to determine vertical angles by using transit or a theodolite. Okay. So echo sounding. The depth of an ocean is determined by using a sonar or the sound navigation and ranging by echo sounding. So sonar uses ultrasonic waves to detect and locate objects underwater. Okay. So ultrasonic wave produced from the transmitter kept in the ship are directed towards the ocean floor. The ocean floor reflects these waves. By measuring the time interval t between the generations of the waves and receptions of the echo, we calculate the depth of the ocean by using the relation d is equals to v by t over 2, where v is the velocity of the ultrasonic waves, and the t is the time interval, and the d is the depth of the ocean. Okay, so this is the formula that we are going to use when we are locating um, when we are measuring echo sounding. Okay, so these are the instruments for echo sounding, or um, we call this echo sounders. The one is the portable photometers. This type may be mounted on a small boat or suspended over the side. Okay, so number two, the non-portable photometers. Non-portable photometers are usually graphic recording and draw continuous profiles as the seabed on a moving strip of paper. Okay, so by the way, these are both photometers, the non-portable one and the portable one. So dredging operations. 1 is the process of widening, enlarging, cleaning, or deepening channels in harbors, rivers, and canals. Okay. Deeper and clamshell dredges are used when the excavated material are loaded into scows, which are towed to a depth water dumping site. Okay. Third, the a, hydro, a, hyd, a hydraulic dredge is another type of dredge which pumps the material to a low-lying areas ashore where it is used as a field, such as in reclamation projects. The fourth one, in dredging operations, the volume of dredged materials has to be determined to ascertain the time required to complete the work and to determine the interim progress of the job site. So, reservoir sedimentation surveys. The construction of dams and reservoirs require extensive topographic and hydrographic surveys. Okay. The impounded water forms an artificial lake or pond called reservoir, in which water is collected and stored, usually for purposes of irrigation, water supply, and hydroelectric power production and transmission. Okay. So, a survey is made of the reservoir site to determine its capacity at various stages of the water surface. A planimeter is commonly used to determine the areas within the successive contour lines plotted on the map. So this is the illustration of material of the planimeter. When silt-laden streams and rivers empty into a reservoir, it is important to periodically determine the extent of sedimentation as well as the loss of capacity within the reservoir. Marine construction and maintenance surveys. The involvement of civil engineer during the early stages in the planning and development of the ports, wharves, harbors, and other marine structures is highly essential. Um, because The role of civil engineers is that to ensure the constructions is safe and sturdy. Okay, so second, data concerning the underwater topography and the character of the bottom material are necessary for the design of marine structures. So tidal information is also necessary when planning for marine constructions along the coast. Next, consequently, it is an important task and responsibility to provide adequate maintenance of these marine structures. Example, a regular maintenance activity is the taking of soundings at periodic intervals to detect and record any changes in navigational depths. Next, hydrographic surveys are also made to determine the extent of sedimentation in some reaches of navigable rivers and channels. So, the hydrographic survey terms. So, hydrography is the study, description, and mapping of oceans, seas, lakes, and rivers, especially with reference to their navigational and commercial or other uses. Second, the hydrographic chart is a type of map or chart used for navigation purpose. It is similar to the topographic map except that the tide fluctuations, navigation markers, water depths, and character of bottom material are indicated. Next is the sounding. It's the process of measuring the depth of the body of water at a particular point. So there is a formula for that in the previous slides. So stream gauging. The process of making measurements in streams and rivers for the purpose of predicting the rate of discharge at various levels or stages. So fathom. A unit used for measurement of water depth and is equivalent to 6 feet. So 1 fathom is equivalent to 6 feet. So tidal datums are the specific tide levels which are used as surface reference for depth measurements in the sea and as a base for the determination of elevation on land. So, discharge. The volume of water flowing past a section of a stream, canal, flume, and other waterways. It is usually expressed in a cubic feet per second or cubic meters per second. Stream. A current or steady flow of water running along the Earth's surface. Dredging. The process of scooping or sucking up mud, sand, rocks, and other material underwater for the purpose of enlarging, deepening, or clearing channels, harbors, rivers, and other bodies of water. Subaqueous contour. An imaginary line on the surface of the Earth found underwater, all points of which are of the same elevation. They are sometimes known as depth curves or bathymetric contours. So that's the end of my report.